Hello everyone, it's the last video. Hot damn. So, the purpose of this video is to kind of answer this question about testing for an association between the predictor and the response in multiple regression. So it's kind of going back to way on page 1 where we were looking at is SAT math score associated with first year GPA even after we account for these other effects like SAT verbal, high school GPA, and sex? One motivation that we just briefly mentioned is that this article from a lawsuit that is saying the SAT and ACT should not be allowed to be used for admissions into the University of California schools, so like the UC, like UC Davis, UC Berkeley, etc. And so we're not, with the data we have, we can't really answer is standardized testing biased. That's kind of like a separate issue. What we can answer is whether for this particular school, since we had 1,000 students from this unnamed school, is there evidence that math is actually useful in predicting first year GPA beyond what SAT verbal and high school GPA and gender can say? So that's kind of the goal. We're going to answer that question through a hypothesis test using our usual steps. And so let's start by writing this true regression equation. And so remember, the true equation means that we don't really know the intercept or any of the slope coefficients. So we're leaving them just as the beta Greek symbol. All right, and so then what we're interested in is whether or not this coefficient in particular, since it's in front of math SAT score, we want to do a test with the null hypothesis that that coefficient is equal to 0 versus an alternative that it's different than 0. In words, what this null hypothesis is saying is that SAT math score is not associated with first year GPA. But it's not just that, it's that it's not associated with first year GPA after accounting for the effects of gender, SAT verbal scores, and high school GPA. The alternative then is that SAT math score is associated with first year GPA after accounting for all of these other effects. What this after accounting for means, you could kind of think of it like if math SAT score wasn't associated with first year GPA after accounting for these effects, it means that like, okay, if I know someone's gender, SAT verbal score, and high school GPA, I don't need their math SAT score anymore. That's like enough information for me. If it is associated with high school GPA after accounting for those other effects, that means that even after I know someone's gender, SAT verbal score, and high school GPA, even after I know that information, I still want to know what their math SAT score is. So that's one way to kind of think about this. All right, and so that's kind of our setup. Model assumptions were already checked, so we're good to go. Our degrees of freedom, so this is one thing that's going to change in the calculation part, is that instead of n minus 2, which is what it was for simple linear regression, it's now this n minus k plus 1, where k is the number of predictors in your model. Really, this worked for simple linear regression too, because we just had one predictor, and so n minus 1 plus 1 is n minus 2. So in this case, our degrees of freedom, we had 1,000 students. We have 1, 2, 3, 4 predictors. So our degrees of freedom are going to be 995. Okay, and so we've already written this fitted model, so I'm not going to go back and kind of explain doing it again. And we've actually written this out a couple times already. So I'm just grabbing the coefficients from that summary output table on page 2. All right. And so from this then, let's find this fitted regression coefficient for SAT math score. That's going to be here. So our B2 is 0.01551. Let's find the t-stat, and so that's in this row as well. Our t-stat is 5.678. Degrees of freedom we already found. And then our p-value is also given in the same row as math SAT score. And so our p-value is 1.78 times 10 to the minus 8. All right, we could do kind of the same stuff that we did earlier when we were introducing hypothesis testing. We could draw this t-distribution, assuming the null hypothesis is true. We could mark our observed t-stat shade the area of both tails to represent the p-value, and have the logic of, well, if this null hypothesis is true, then what we actually observed was like super, super strange. Therefore, I'm going to conclude that the null hypothesis can't really be true, and there's a lot of evidence for the alternative hypothesis. And so I'm going to jump to the conclude just to kind of get that sentence done and over with. So in my conclusion, I would say, okay, there is strong evidence. And then just like always, we're just writing the alternative hypothesis in context of the problem, which we've actually already written out what the alternative hypothesis is. So that's pretty easy once we have that step. So there's strong evidence that math SAT score is associated with first year GPA. And I'll just say even after accounting for the effects of high school GPA, gender, and verbal SAT score. Give our t-value that we wrote on the previous page, as well as our p-value. So at least our conclusion is saying that math SAT score actually is useful for predicting first year GPA, even after we account for these other effects. And so that kind of goes against what some of the things that are said in that article, that the math SAT or verbal SAT aren't really useful after you take into account a student's high school GPA. Okay, so this is awkward. I was excited that this would be the last video, but it's actually not going to be. So we're going to have like another probably 4-minute video to talk about this confidence interval as well as the interpretation. Ooh, awk. Okay, so see y'all in a sec.